given here, given below, right? To convert between degrees and radians, use the proportion theta over 180 equals theta r over pi. Okay, so where theta is the measure of angle in degrees, and theta r, theta sub r is the measure in radians. Okay, all right. So this is the theorem we discussed in last class, and today we're going to continue with this example. Okay, Natalie, can you read it first, please?
Yeah. Find its measure in radians. B, if an angle is negative 120 degrees, find its measure in radians.
Very good. Thank you. All right. Very good. Let's do this one, right? So let's do this one together for A. Okay, solution. Okay, so the angle, the measure in degrees is 30. So we have theta equals what? 30, right? Theta equals 30. Now it's a measure in radians. Let theta r be its measure in radians. All right, then we're going to use what? We're going to use this one, this relation. So based on the theorem, hence we have what? Theta over 180 equals theta r over 2 pi. Yeah, this is the theorem we have here, right? Over pi, sorry. Not over 2 pi, here is over pi. Does that make sense? Okay, so we have this. Theta r over pi equals this one. So this means by this implies, all right, this implies, now theta equals 30, so 30 out of 180 equals theta sub r over pi. Does that make sense?
Mm-hmm.
Okay, now let's see that then if we multiply, well, let's do this. Multiply pi on both sides. All right, pi times 30 over 180 equals what? Pi times theta sub r over pi. So this is a multiply pi on both sides, right? So this will be exactly the same, right? All right, so it implies that this is true. Now, you can see that this side is pi and pi cancel out, right? Pi and pi cancel out. And 30 and 180 is what? If you divide 30, 180 is 30 times.
Is it 1 over 6?
It's 1 over 6. Yes. Very good. All right. So this implies. Now, I'm going to write theta r. Well, this is an equation. So I can write it in this way, right? So theta r equals what? Pi times 30 over 180. Now 180 is 30 times 6. Yes, 180 can be written as 30 times 6. So now 30 and 30 cancel out. So this is 1 pi times 1 over 6, which equals pi over 6. Now that is hence what? Theta r equals pi over 6. Does that make sense?
Mm-hmm.
Okay, very good. Now, what about, can you find out B using similar method? Can you go ahead and try if you can find B? Go ahead and see if you can find this.
2 pi over 3 equals radians r. Okay.
Okay, all right. Some of us already got the answer. All right, so now let's check this question together. Okay, so for this one, for B, right? So we have theta equals negative 120 degree. All right, negative 120. So by this theorem, we have this equation. This equation always holds, right? This is from the theorem here. All right, it's theta over 180 equals theta r over pi. Now, using the same trick, all right, we are going to, well, firstly, by substitution, because theta equals negative 120, so we have negative 120 over 180 equals theta sub r over pi. Now, which implies, all right, if we multiply pi on both sides, all right, so pi times negative 120 over 180 equals pi times theta r over pi. So pi and pi cancel out, right? So that's the theta r. So that's theta r here. Now, the next thing is, well, here is the product, right? You can use the calculator to find this one. Negative 120 over 180. Using the calculator, you find that what? Now, if you're using the, if you change it to a fraction, if you simplify this fraction, you should get, this is negative 2/3. Did you get this?
Yep.
Okay, anybody else questions? Yeah, make sure that you know how to do that. Or in different calculators, you should be able to find out either using, sometimes the calculator will return you a decimal points, right? So in decimal numbers, like this one sometimes will be negative 0.666667, right? But if you convert it to fraction, you will get negative 2/3. Okay, so just make sure that you know how to use the calculator to do the conversion, right? From a decimal to a fraction, from a fraction to a decimal. Okay, make sure that you know how to do that. Now this one is a pretty simple one. It's negative 2/3 times a pi, right? So therefore, theta r equals, theta sub r equals negative 2/3 times pi. Okay, very good. Now in the future, now what do we do, right? So given an angle in degrees, right? So we set up the equation, multiply both sides by pi, and find out theta r, right? Find out theta r.
Right.
Okay, that's how we do this. Okay. Let's now try to do the other way around, right? The other way around. Okay. Let's say, Salim, can you read it for us, please?
If an angle is pi divided by 4, find its measure in degrees. B. If an angle is negative pi degrees, find its measure in degrees.
Oh, sorry. My typo. Thank you. Thank you, Salim. Very good. All right, this should be in radians. All right. in degrees. Sorry, it's good. All right, there's no in. All right, so in degrees. Okay, so here now I'm going to solve for A, and then you try to solve for B. All right, so solution. Now this whole angle is given as pi over 4. Since there is no unit, as we said, if there is no unit is given, it is measured in radian. Right? So here, since there is no unit is given, so we know that this pi over 4 is in radian. So we have theta r equals pi over 4. Okay? And let theta be its measure in degrees. Okay? So then we have again that what equation? Theta over 180 equals theta r over pi. Okay, so which by substitution we know theta over 180 equals what? Equals pi over 4, right? Pi over 4. I'm going to write this way over what? Over pi. Yes?
Pi.
Over pi.
Mhm.
And then now to find out this theta, what we can do is times, okay, for this one, right? So we can divide by pi on the top and the bottom. So we will get the same. Theta over 180 equals, right, pi over 4 times 1 over pi times 1 over pi. So basically what I do is I just multiply the same quantity 1 over pi on the top and the bottom. Then I got exactly the same, right? So this will be pi over 4 over pi is the same. Now, however, by doing so, I can see that pi and pi cancel out. On the top, it becomes 1 over 4 times 1, right? 1 over 4 times 1. And this one, pi and pi cancel out. That's going to be 1 times 1. Yes? Okay. So now on the top is 1 over 4. On the bottom is 1. So it is just 1 over 4. Does that make sense? Okay. Now, by doing so, I found that pi theta over 180 equals 1 over 4. Now, if I multiply 180 on both sides, okay, so theta over 180 times 180. This equals what? 1 over 4 times 180, right? Okay, so because theta 1 over 80 equals 1 over 4, so I can multiply both sides by 180, and I got this equation. On the left-hand side, 180 and 180 cancel out. On the right-hand side, you can find this one, right? So this one equals what? 180 divided by 4. What did you get?
45.
45. Okay, that's very good. All right, so that's 45. Theta equals 45. Okay, now Hans, as measuring degrees is 45 degrees, right? Right, so theta equals 45. That is our answer. 45 degrees, right? 45 degrees. Now, this is our A. And could you go ahead and try to see if you can find B, please? All right, see if you can find B. Okay. Anybody got the value? What is the value for theta?
Negative 15 degrees.
Negative 15 degrees. Okay. Negative 15 degrees, right? Okay. Very good. Okay. So did you see how to convert a degree, an angle in radians to degrees? Okay, so this, okay, sorry. This is not in degrees. This is just radian, right? This is just radian. Okay. All right, so this is how we do, right? So basically, the key point is to set up this equation. All right, set up this equation using the theorem. All right, as this equation is always true. Theta over 180 equals theta sub r over pi. All right, and then you do algebra, right? You do algebraic operations, and try to express theta in terms of these ones, right? So you divide by pi on top and bottom, and then multiply by 180 on both sides, right? And then you can get this value. Okay, so very good. Now, let's move on to the next topic. Okay, so this is the so-called coterminal angles. Now, as we know, for this angle, we know that it is, the angle can be created by rotation of the sides, right, around the vertex. You rotate one circle, and you rotate for an angle, and you got this position, and then that is our angle. Now, however, so if you rotate this one, you can rotate actually for several full rotations, and you can come up with to the same position, right? So you got to this position, and if you do another full rotation, you return to the exactly the same position. So in other words, so there are angles which are sharing what? The same terminal sides. Okay, so that's what we mean by coterminal angles, or two angles in center position that have the same terminal sides. So let me just draw this. Let me just draw this one here. Okay, so this is in the standard position, this is x, and this is y. So if this is my angle, right? So this is, you can do this one and end up at this position. This is one angle. Say that this is angle alpha, right? So this is alpha. Now, or you can do this one, right? So you do one circle and then come back at this point. You do one full rotation and then another alpha, right? So say this can be what? Beta. Now you can see that alpha and beta ends up at the same terminal sides. They have exactly the same terminal sides. In this case, we say they are what? Coterminal angles. Right here, alpha and beta are coterminal angles. Does that make sense? Okay, so can I have another full rotation? Yes, you can do another full rotation and come back at the same terminal side, right? Got the same terminal side. You can do multiple rotations, full rotations. As long as they share the same terminal side, they are what? Coterminal angles. All right, so in other words, there are many coterminal angles. Okay, there are many coterminal angles. Okay, now let's just consider this example. All right, and I found this. Arinda. Is Arinda?
Yes.
Okay, Arinda, do you have? Okay, okay, I can hear you. If you don't mind, you can read this question for us, please?
Yeah. Find the least positive angle theta that is coterminal with an angle measuring 800 degrees, where 0 degrees is less than or equal to theta, which is less than or equal to 360 degrees.
Thank you, Arinda. Am I right? My pronunciation of your name, is that right?
Yes, surprisingly, no one else ever gets it, but you did.
Okay, cool. Thank you. All right,
Yeah.
Arinda. Okay, let's do this one together. All right, so let's do this one together. Now, what we want to do is we want to find the least positive angle theta that is coterminal with 800 degrees. All right, with 800 degrees.
Mhm.
You can see that 800 degree is what? Is a pretty large one, right? So we know that one full rotation is how many degrees? Is there in
360.
360 in one full
Mhm.
rotation, right? 800. That's more than 360, right? We see that 800 degree is greater than 360 degree. So it is definitely goes one full rotation and then come back, right? And then it will go, can it go another full rotation or not?
Yes.
Yes.
Yes. So 2 full rotations. What is 2 full rotations? What are the degree for 2 full rotations?
720.
720. Yeah, that is 360 times 2, right? Equals 720 degrees. Now, for 2 full rotations, well, I still have 800 is greater than 720, right? So, and then can I go another full rotation?
No.
No, I don't need that much, right? Because after 2 full rotations, we only remaining what? 800 minus 720, that's what?
80.
80 degree.
80 degrees, right? So that's not a full rotation anymore. So that's 80. Okay, so now the question is 80 the least positive angle, which is a
Yes.
coterminal with 800?
Yes.
Yes, right? That's the least positive one, right? Because it must be coterminal with 800, and you need to do this one 2 full rotations. You come back to the same place, and then you need to another 80 degree. All right. So therefore, we will have So for this type of questions, what shall we do? All right. What shall we do? Okay. So now here is what we do. All right. Solution. Since one full rotation equals 360 degrees. 360 degrees. All right. Then two full rotation equals what? 360 times 2, which equals what? 720 degrees. And 3 full rotation, that's going to be 360 times 3, which equals what? 1080, 1080, right? 1080 degrees. Now we don't have to go more because what? We found out that 800 is right between 2 full rotations and 3 full rotations, because this is a 720, this is 1080, right? Now, since, all right, so 800 degrees is between 720 degree and 1080 degrees. We have, all right, so what do we do is we're going to use 800 degrees minus what? Minus the lower one, all right, the 2 full rotations. All right, so this is what we do, all right? So 800, therefore, okay, Hans, let me not, we have, okay, so let's say this. Hans, the least positive angle, all right, is what? Using theta equals 800 degrees minus what? 720 degrees, which equals 80 degrees. Okay, which equals 80 degrees. Okay, between 80 and 800, it's just 2 full rotations, right? It's just 2 full rotations. Therefore, they are coterminal, right? They are coterminal. So therefore, and it's the least positive angle. Why? Because what? The 800 is between 720 and 1080 degrees. So therefore, it's at most, you go back for 2 full rotations, right? Then you got the least positive. Now, if you go another full rotation, it's going to become negative. Yes? You cannot do one more full rotation because that's going to be negative numbers. All right, very good. So we got this one, right? So this is how we do so, right? So in order to find the least positive angle that is coterminal with angle that is large, right? So like this one is 800 degrees. Now you try to find the coterminal positive angle theta, which is between 0 and 360. Okay, now let me just, can you please go ahead and see if you can find, instead of 800, all right, can you find how about 110, 11,000 degrees. Now, can you find, all right, go ahead and see if you can find the least positive angle theta that is coterminal with an angle measuring 1100 degrees. Can you find that? Okay. Some of us already got this one. All right. So it's 20 degrees. All right. So we can build up on this previous this example, right? So as 1 full rotation is 360, 2 is 720, and 3 is 1080 degree. Now, if you know, it's easy to know that 4 rotations is going to be what? 1440 degrees, right? 1440 degrees. And we know that 1100 is between what? Is between 1080 and 1440, right? It's between that. So therefore, my theta is what? 1100 minus 1080. That's going to be just 20 degrees. That's going to be 20 degrees, right? So I believe that if you do more example, if I give you another example similar to this, you should be able to find this. All right. So just to find out find out full rotation, how many full rotations it contains, right? It contains, and then subtract from it, and you can get the least positive angle. All right, so this is for an angle that is positive and larger than 360. All right, larger than 360. Now here, consider another example. All right, we have another example here. Joshua, can you read first, please?
Yes. Show the angle with measure on the circle and find the least positive angle theta that is coterminal with it, whether between 0 degrees and 360 degrees.
Very good. Thank you, Joshua. That's very good. All right, so let's do this one together. All right, so I'm going to show this one. All right, so I'm going to firstly show this one on a circle, right? So let me just draw this one in a standard position. Okay, on a circle. So let me just draw, sketch a circle here. Okay. All right, I'm sketching. All right, it's not perfect. Okay, it's actually very bad. All right, so negative 30 degree. So negative 30 is 1/3 of 90, right? So it should be something like this. It's going what? Clockwise, right? So because it's a negative angle, right? It's a negative angle. So it's going counterclockwise, clockwise. All right, so it's something like this here. So this is an angle with negative measuring what? Negative 30 degrees. Okay, so now we want to find the least positive angle that is coterminal with it, where theta is greater than that. Okay, so for this one, let's see how we do this. All right, solution. Now we want to find what? A least positive angle. A least positive angle. So now our angle now is negative. It's a negative value, right? So in order to find a coterminal positive value, you got to do what? You got to rotate this angle counterclockwise, right, for some full rotations. Is that right? Is that right?
Hmm?
Okay. So now again, right? So and for this one, I believe you just do one full rotation, right? If you just do one full rotation, that's going to be enough because it's a negative 30 degree, right? So here again, since one full rotation equals 360 degrees, we get the least positive angle theta, okay, which is that is okay. Okay, let me just say the least positive coterminal angle theta. We can get this one by full rotation counterclockwise. Counterclockwise, right? So that is what? Theta equals 360 plus, well, let me do this one, all right? Because we're starting from negative 30, right? So it's negative 30 degree, and you counterclockwise, so plus a full rotation plus 360. That's what? 330 degrees.
3/3.
Yeah, 330 degrees, because it's 360 minus minus 30, right? Minus 30, so 330 degrees. Does that make sense? Okay. Now, sometimes if you cannot get the positive value in one rotation, then you may do another rotation. Does that make sense? You may do another rotation. All right. So for instance, let me just give you another example. and see if you can find. So what about this one? With so that angle with measure instead of negative 30, it is negative 400 degree. So how about this one? Can you find out the least positive angle that is coterminal with negative 400 degrees? Now for this one full rotation is not enough. Okay, so what shall we do? Okay, all right, so let's do this one. Some of us may already got this one, or let's do this one, right? So now for negative 400, because one rotation is not enough. You can see that, right? Negative 400 plus 360 is negative 40, right? Which is still less than 0, right? We need what? We need some value that is between 0 and 360, right? So you need to do another full rotation, right? 2 full rotations. So that's why we're doing negative 400 plus 2 full rotations, right? 360 times 2. Now, which gives us 320, right? Now, 320 is between 0 and 360, right? 360. So therefore, this is the 1, right? So therefore, theta equals, hence, theta equals 320. Okay, so you need to know how to do so, right? Does that make sense? If one rotation is not enough, go for another one, right? If it is still not enough, another one, right? So we continue doing this until you got the first positive angle. Okay, so all right, now let's consider this one. For the previous 2 examples, is always measuring in degrees. Now, let's do an example that is measured in radians. Okay, Nick, can you read for us, please?
Find an angle theta that is coterminal with 18 pi over 3, where 0 is less than or equal to theta, which is less than or equal to 2 pi.
Very good. Thank you, Nick. All right, let's do this one together. All right, so solution here. Now, since there's no units, right? We know that they are measured what? In
Radians.
radians, right? In radians. Solution. Since 1 full rotation equals 2 pi, right? Equals 2 pi. Now, 18 over pi, okay? So you can see that you can, what is 18 over pi? 18 over
pi.
3. 18 over 3. 6 pi, right? Oh, that's just a 6 pi, right? So that's just 6 pi. We can let's just change another number, 19. All right, instead of 18, let's change it to 19. Okay, so let's change to 19 pi instead. Okay, 19 pi. Since 1 full rotation is 2 pi, and then 19 over 3 is 6 pi, right? So 2 full rotation is going to be what?
4 pi.
Oh, that's going to be 2 pi times 2, which is 4 pi. right? 3 full rotation equals 2 pi, right? And 4 full rotation equals 2 pi times 4. That's 8 pi. Now, let's just be careful, right? So now 6 pi, now we are trying to find that the angle is coterminal with 19 pi over 3, right? 19 pi over 3. Now 6 pi is what? 6 pi can be written as 18 over 3 times pi, right? It's 18 over 3, right? Now this one is 24 over 3 times pi, correct? So you can see that 19 over pi over 3 is between 3 full rotation and 4 full rotations. Yes?
Yes.
Okay. Since 19 pi over 3 is between 6 pi and 8 pi. All right. So the angle, the coterminal angle, theta is what? Theta equals 19 pi over 3 minus what? Minus 6 pi, right? Minus 6 pi, which is 19 pi over 3 minus, now 6 pi is 18 pi over 3, okay? Which equals what? We have the same denominator, so 19 pi over 18 pi over 3, which is what?
1/3 pi.
Yeah, pi over 3. That's 1/3 pi. Any questions on this one? Okay.
Where did we get the 18 pi?
Oh, 18 pi, right? Okay, very good
Yeah.
question. All right, so 6 pi. All right, what I did is, now since this is 19 pi over 3 minus 6 pi, I want to put them with what? The same denominator, right? So because here is 19 over 3, I want to change this 6 pi into something like this, all right, which is what? It's the same as the 6 pi 3 over 3. Is that right? Okay. Now, because 3 and 3 cancel out, that's going to be exactly the same, right? So which equals what? On the top, 6 pi times 3 is what? 18 pi. On the bottom, that's a 3. Does that make sense?
Okay.
Now,
Yeah.
very good. Very good question. Right? Why we are doing this? Why we are doing this, right? So we are doing this because now I want to put them with the same denominator, right? Because the first one with the denominator of 3, so I want this 6 pi is also with the denominator 3 so that I can do the subtraction, right? So this means what is 19 pi minus 18 pi over 3 because they share the same denominator. Okay, so therefore we have pi over 3 here. Good? Okay, very good. All right, let's consider another one. All right, so let's consider this one. Mustafa, can you read for us, please?
Show the angle with measure -1 on a circle and find the least positive angle of theta that is coterminal with it, where 0 is less or equal to theta and theta is less or equal to 2 pi.
Very good. Thank you very much. All right, that's good. Let's do this one. All right, together. All right, show the circle is -1. All right, you can just sketch the position in a circle. All right, -1. -1 is, well, if this is the radius, and then I need to do arc, which is the same length as the radius. So maybe somewhere here, right? So this angle is going to be what? -1, right? -1 is going clockwise. It's -1, right? So now for this one, I can do what? If I want to find some coterminal angles with it, so I need to rotate 4 rotations, right? 4 rotations. I got a coterminal ones. Now for this one, what I want to find is between 0 and 2 pi. Between 0 and 2 pi. So I can just do 1 full rotation counterclockwise or clockwise.
Counterclockwise.
Yeah, counterclockwise, right? Because they need to do positive one. You need to add something, right? Because this is a -1, and this is you want to find some positive values, so you need to do counterclockwise, right? So now, since what you how many full rotations do I need in this case for this one? How many full rotations do I need? I believe what?
1.
Maybe 1.
I believe it's just why it is just 1 full rotation is needed. Because I know that 2 pi is a 1 full rotation, right? 2 pi is about what? It's about 6.2 or 6.3, right? Which is definitely, if you add a 6.2 to -1, that's 5 something, which is between 0 and 2 pi, right? So we need 1 full rotation counterclockwise. Okay, so that is what? Theta equals -1 plus 2 pi, which equals, you can use the calculator to find this value, all right? So you better round it to, or you can just write it in this way, all right? So, but if you want to get a decimal point, now you can always do using the calculator. Anybody can find this pi?
A decimal or you got
How many decimal places? 4 decimal places, if you want, if you please.
5.2831. 5.2831.
3.1. If you did you round it to?
No, 5.2832. Sorry.
3.2. Okay, 3.2.
Yeah.
All right. So you round it correctly. All right. Be careful on that. 5.2832. If you round to 4 decimal places. Okay. So that's how we got it. Is this one between 0 is positive, right? And also less than 2 pi, correct? Which is good, right? Which is good. Now, of course, for some value which is really small, right? For instance, I can have -10. If it is -10, then it's going to be a different story, right? So you need to one full rotation is not enough. In this case, how many full rotations do you need?
2.
2. Okay, 2. Very good. All right, 2 full rotations. Why we need 2 full rotations instead of 3?
Because each rotation's 2 times 3.14.
Yes.
So,
all right, so you can just try, right? You can just try it out, right? So if it's -10, is -10 plus 2 pi equals what?
Negative 3.717.
Negative. Can repeat it, please?
3.7168.
Yeah, since it's still negative, right? If you do the 1 full rotation, it's still negative. Is that -3? Yes. It's still less than 0, right? Still less than 0. So you need another rotation, right? So you need 2 rotations times 2, right? So and therefore this one equals what? This one equals what? What is this one?
2.5664.
64, right? Be careful in you run it correctly, right? 2.5664, right? So this is between 0 and 2 pi, right? This is already between 0 and 2 pi, correct? So you do not need another one. Yes?
Yes.
Okay, very good. All right, so that's very, very cool. We got this one right. Okay, so now for this ones, you can see, all right, if we need to be able to find some angles that is coterminal with a given angle, right? With a given angle. So now for this one, we are usually interested in the angle between 0 and 2 pi, all right, within a full rotation. Right, within a full rotation. Now, of course, these two examples are in radians. Now, the previous two are in degrees. We should be able to do both, do the problems in both cases. Okay, so that's very important. Now, let's move to the next step, which is very interesting. That's determining the length of an arc. Okay, determining the length of an arc. Okay, so consider the following theorem. In a circle of radius r, the length of an arc S subtended by an angle with measure theta in radians. All right, be careful. This is in radians. Is S equals r times theta, just the product of the radius and the measure in radians. That is what? The arc length. That is the arc length. Okay, so that's basically what we have. Now this arc length is denoted by S. All right, now this one is theta, and this is r. All right, so r. Now where, okay, be careful, where theta is greater than 0. All right, we do this, okay. All right, the arc length is given by this, okay. Well, sometimes you may do the negative arc length. All right. Usually we're talking about the theta is between 0 and 0 not to 360, but 0 to 2 pi. Measured in radians. Okay, measured in radians. Okay. Now, in some textbooks, they may define what? They may define something about the so-called negative length. All right, the negative arc length, but a majority of the cases, the arc length is positive. All right, we say the arc length is positive. Okay, so now let's consider this one example here. All right, so let's consider this example. Let's just say, okay, 中序.
Find the arc length along a circle of radius 5 subtended by an angle of 2.2.
Very good. All right, thank you very much. That's very good. Okay, so let's just sketch this one first. All right, it's better to have a sketch, right? Better to have a sketch of the angle xy. Okay. The angle is 2.2. Which quadrant it is located in? If it is 2.2, I know that the half circle is what? Half a circle is pi, right? Half circle is pi. I know that pi equals what? 3.14, something like this. Something like this, right? Pi is less than 3.2, right? Now then pi over 2 is what? Pi over 2 is the right angle, right? It's a right angle, right? Pi over 2 is the right angle. So that's approximately what?
Would it be in the second quadrant?
Yeah. So pi over 2 is 1.57 something. Okay, so because this is 2.2, which is between, all right, since 2.2 is greater than pi over 2, less than pi, it's terminal. Its terminal side is in the second quadrant. All right, so it should be somewhere 2.2, right? Let's say that it's something like this.
Mm-hmm.
Okay, so what we want to find is this loss. I know that this angle is 2.2. All right, so the radius is what? It's 5, right? And here is S, right? So I want to find the value for S. So hence, by the theory, arc length is the product of R and theta, right? Theta is measured in radians.
Mm-hmm.
Arc length is what? Is S equals 2.2, which is the angle radius R times the theta. R is 5. What do we get?
11.
11. Very good. All right, so that is our answer. That is our answer. Okay, so arc length is 11. All right, it's 11. Very good. Okay, so if I give you another angle, what about if I have an angle that is 1.4? If the angle is 1.4, then the S is going to be what?
7.
7, yes. In this case, right? So if the theta equals 1.4, then we will have this. All right, so basically it's just what? The product of the radius and the angle measured in radian, right? That gives us an arc length.
Mhm.
Okay, now sometimes we may given in this example, all right? Sometimes we are not given directly in radians. In those cases, we have to convert the degrees, the measures in degrees into what? Into radian, and then use the formula. All right, let's consider this example. Jared, can you read for us, please? Jared, you're muted. Can you unmute yourself?
He said his mic is not
Oh,
working.
it's good. It's good. It works. Jared? I think you're muted. Okay. But right now it's just worked a little bit.
That was me. That was Mustafa.
Oh, okay. Okay, I see. Then Mustafa, can you read for us?
Okay. Find the arc length along a circle of radius 10 subtended by an angle of 215 degrees.
Yeah, 215 degrees, right? So very good. Could you, yeah, go ahead and see if you can do this. Firstly, convert 215 degrees into radians, all right? So do you remember how to do that? How to convert a degree to radian, right? Do you remember how to do that? Firstly, do this one, all right? So solution here, all right? Theta equals 215 degrees. Let theta r be its measure in radians. All right, very important. You have to firstly transform it from degree to radians. All right, this is very important. Okay. Now remember how to do that? Okay, anybody found this r? Say the r equals what?
I got 43 over 30, 43 pi over 36.
40 what?
43 over 36, 43 pi over 36.
Over 36?
Yeah.
Okay. Okay, good. All right, over this one. But can you get the I mean in a decimal point? What about in a decimal point?
1.19 for repeating.
1.19. I mean times pi, including pi, times pi.
Oh, times a pi?
Yeah.
What do you mean?
3.7525.
7525. Okay. Yes. Very good. All right. So this is what I mean. All right. You can just now you can just multiply them together and get a final result instead of just including pi. All right. Because now you want to find the value, right? Find the value. So you can just do this. All right. Round to 4 decimal place. 3.7525. All right. Make sure that you round it correctly. All right. So 3.7525. Is that right? Okay, very good. Okay, now hence the occurrence is what?
Is
S?
3.75 times
Okay.
10.
Yes, it is. This one is the radius. All right, be careful. Theta times r, or theta sub r, right? It's measured in radian. Okay, so it's 10 times 3.7.525. Good. Does that make sense? Okay, very good. All right, so just to be careful. Now for this question, because the angle is given in degrees, we have to transform it to convert it to radians, right? To measure in radians. And then use the theorem to find out the length of the arc. Okay, so be careful on that. Now let's consider next one is determine the area of a sector of a circle. All right, so consider this theorem. The area of a sector of a circle with radius r subtended by an angle theta measured in radians is A equals 1/2 theta r squared. Okay. So again, I'm going to sketch, make a simple sketch here. Okay, so say that this is theta and is this sector. All right, here, okay, again, where theta is between 0 less or equal than 2 pi. Less or equal than 2 pi. Okay, so so this is called as the area of a sector of the circle. All right, so theta equals 1/2 pi theta r squared. Okay, now this is of course for any angle, right? For any angle theta between 0 and 2 pi. So in the special case, when theta equals 2 pi, we have what? If theta equals 2 pi, what do we have? Times 2 pi times r squared, right? Now 2 and 2 cancel out. Did you see that? 2 and 2 cancel out. So this one equals what? Sorry. Okay, where am I?
Area of the circle.
Yes. Okay, just 1 second. So this one is going to be just simply pi times r squared, right? Do you remember this one? This is the area of a circle, right? So which is a special case when theta equals 2 pi. Good? Okay, very good. All right, now let's consider a question example. All right, so are you guys ready for the example? Okay, I see Natalie is writing something. Okay, all right, so let's move on to this one. All right, move on to this one. Natalie, can you read it for us, please?
Yes, 1 second. Find the area of a sector of a circle of radius 3 subtended by an angle of 2.1.
Very good. All right, very good. Okay, so go ahead and see if you can do this. So solution here, r equals to 3, theta equals 2.1. Now, since there is no unit, so this is already measured in radian. Okay, this is already measured in radian. Hence, the area is A equals 1/2 times theta times r squared. So which is 1/2 times 2.1 times 3 squared. Okay, calculator, please. Anybody got it?
9.45.
9.45. Okay, very good. Okay, any questions on this part? Are you able to find this value? 9.45?
We don't have to write any units on that, right?
No, you do not, because there is no unit for the radius, right? If the radius is given, then you need to add. If it's in meters, you do meters. If it's in feet, you do feet square, right? So, but now, because we do not include the meters here, right? So we do not include any units. Very good question. Okay. All right. So perfect. Okay. Consider another example here. Okay. Let's see. Nick, can you read for us, please?
Yeah. An automatic lawn sprinkler sprays a distance of 20 feet while rotating 30 degrees. What is the area of the sector of the grass that the sprinkler waters?
Okay, very good. Anybody have such experiences? the automatic lawn sprinkler, right? So usually we like take a walk in our neighborhood with my wife and daughter, and sometimes they set this thing, right? This sprinkler, and it spreads out also to the sidewalks. Okay, this happens very often. Now let's consider this one, right? So automatic, this one. So we want to know the area it covers, right? The area it covers. How do you think? Can you go ahead and try, if you can? Now here you have to be careful, right? It's rotating 30 degrees. 30 degrees, all right? It's in degree. You got to firstly transform it into radians, right? And now another thing is this one has a unit. If the distance is 20 feet, then the area is going to be in what? The area is going to be, the unit for area is going to be what? Square feet, right? Square feet. Okay, so could you please go ahead and see if you can solve this question, please? Find the area of this one. All right, now sometimes it's better to draw a mathematical model, all right, which means what? You can just do something like this, right? So set this sprinkler in the origin, right? So and then 30 degrees, it is something like this, right? This is 30 degrees. And then what you want to find is basically the area of this slide, right? So the distance here is 20 feet, 20 feet, okay? So now, tell me if I'm right. I think the area equals what? Equals 1/2 times theta times r squared times 20 squared. Is this right?
Radians.
Mustafa, could you say that again?
We have to convert to radians from the 30 degrees.
Yes, exactly. Very good. All right. So this is wrong. This is wrong. All right. So in order to use that theorem, theta needs to be converted to radians. All right, to measure in radians. So this is very important. Okay, so go ahead and see if you can do this.
Okay.
Okay. Calculator. Anybody got this one, please?
104.7198 feet squared.
104 point what?
7198 square feet.
798. Okay, square feet or feet square, right?
Mhm.
104.7198. Okay. Does that make sense? Anybody got this value, please? Good?
Yep.
Okay, very good. All right, so this is basically how we do so. Now, one thing is very important is the one important thing is we need to convert the angle to radians if it is not in radian, right? So in this case, you have to firstly convert it into radians and then do so. Okay. Okay, all right. We have another 5 minutes. Let's just do this one. Move on to section 1.2, right angle trigonometry, right? Right angle trigonometry. Okay, the goal for this section is use right angle to evaluate trigonometric functions. All right, like sine, cosine, and etc. All right, find the function values for 30 degrees and some special degrees, special angles, and use equal cofunctions of complementary angles, and use the definition of trigonometric functions of any angle. Okay, so now let's consider this one. All right, so trigonometric function of an angle theta using size of a right angle. Now we have for a right triangle. All right, so for a right triangle, let me draw a right triangle here. Sketch. I'm just sketching. All right, say that. Okay, say this is A, this is B, and this is C. All right, so that this is our theta. So this is our theta, right? So for this one, this is a right triangle. So I'm putting this one here. It's a right triangle notation. It's a corner, right? A corner. There's a right triangle. So for this one, what do we have? We can say that they have 3 sides. All right, so adjacent side. So adjacent side is the one which is close to the angle here, but it is one side of the right triangle. All right, so it's shared by this angle and the right triangle, which is adjacent side. So this is adjacent side. Okay, the opposite side of theta, it is the side opposite to angle theta. Okay, so this is opposite side. And then this one, right, is called the hypotenuse. Is that right?
Mm-hmm.
Hypotenuse. Is called hypotenuse. All right. So these are the the names of the 3 sides depending on the angle theta. So theta is given here. So this called adjacent side, and then the opposite side, and this one is the hypotenuse, right? Hypotenuse. Then, all right, we are going to define the following trigonometric functions. All right, then the sine of theta. Okay, the sine of theta is going to be the ratio, the fraction of what? The sine is the opposite over hypotenuse. Okay, so it is opposite over hypotenuse. Okay, so this is the sine. Sine of theta is opposite over hypotenuse. Now cosine is what? Is the adjacent side over hypotenuse. And tangent theta is what? Is the opposite side over the adjacent side. Over adjacent. Okay. Did you see the definition here? Okay. Very good. All right. So I think it's already time. I would love to give an example, one example illustrating this, but we will stop here and